All right, B5 homework. So this is simplifying radicals. All right, so let's go. Number 1. 81 can be rewritten as 9 times 9. So it's already a pair. So that comes out as a 9. Now it's a square root. So we're looking for how many sets of 2, how many groups of 2 are in 4? Well, there's 2, right? Because this is really x 4 times. So there's 2 sets of 2. So x squared comes out. And then how many sets of 2s are in 3? Just 1, with 1 left over. Right? Because that's y times y times y. And there's 2. Right? There's a pair. There's a square root and then a single y left over. All right. Number 2. Same idea. 54. We can do this 2, 26. That's not true. 27. And then 3 and 9. 9's 3 and 3. So here, the pair that's going to come out is a single 3. Right? And it's going to multiply against this 4. So 3 times 4 is 12. And then 2 and 3 are left over. So root 6. The leftover parts multiply. Okay, root 8. 8 is 2 and 4. 4 is 2 and 2. So a single 2 is going to come out. All right, so a single 2. And then there's 2 x's, so that's a single x. And then there's 3 y's, so a single y with a y left over. Don't forget about the 2, right? There was a 2 left over, and then there was a y left over. Right? Because I'm not going to do this every time, but there's a pair of x's, and then there's 3 y's. So you're always thinking in sets, right? Sets, groups of 2, sets of 2, however you want to think about it. For 80. So 80, 2 and 40, 2 and 20, 2 and 10, 2 and 5. So the group, the pairs, there's 2. 1, 2. So the 2's come out, they multiply to make a 4. And then the 5 is left behind. Right, singles stay behind. Singles stay behind. Okay, here we have a cube root. So now we're going to look for triples. Right, not pairs, not doubles, but triples, 3s. All right, 64. 2 and 32. 2 and 16. This is 2 and 8. And this is 2 and 4. This is 2 and 2. So triples, we have 1 set of triples, 2 sets of triples. So these are going to come out as single 2s outside. So far we have 2. Then x to the 6. So how many groups of 3? 2 groups of 3. So that's coming out. And then there's 3. So a single y is going to come out. So what's left behind? We have cube root of nothing. Everything came out. Everything came out. So that's good. Actually, 2 2's came out. So this should be a 4. This should be a 4, not 2. My bad. Right, because these multiply. Okay. All right, we're adding. So we can only add if the square roots match. So this is 3 and 9. This is 3 and 3. Again, a pair is going to come out as a single 3. There's already a 3 there, so 3 times 3 is 9. Root 3 is left over. This is minus 7 root 3. And then lastly, 12 is really 3 and 4. 4 is 2 and 2. So that's going to come out. So minus 2 root 3. So they all have root 3s, right? They all have the same label. So this is 9 minus 7 minus 2. That's crazy. Because 9 root 3 minus 9 root 3, right? Negative 7 and negative 2. Well, 9 minus 9 is just 0. That's wild. Five root 3 minus 4. Again, they match. The square roots match. So think of this as like a label, like inches, right? 5 inches minus 4 inches, 1 inch. Think of it like apples. 5 apples minus 4 apples is 1 apple. So the answer to this is 1 root 3. 5 take away 4, root 3. 8. So here we're combining like terms. We have a root 3 and a root 3. So 2 root 3 plus 7 root 3 is 9 root 3. And then 5 minus 2. 5 minus 2 is 3. Positive 3. As much as we can do. Okay. We have root 3s or cubed roots. So they match, right? They match. At least the cubes do. So now they just need to have the same label. So 40 is really 2 times 20, 2 times 10, 2 times 5. So the triple, right, because it's a cubed root, is going to be 2 cube root 5 minus 2 cube root 5. That's silly. 2 minus 2 is going to be 0. Why do they do that? All right, number 10. Okay. Let's do it like this. We have to simplify the inside at the end of the day. 20. We've done this already, but let's just keep doing it. So the pair is going to come out. So that's going to be 4 root 5, right? Because 5 is left over. Okay. 45 is really 5 times 9. 9 is 3 times 3. So 3 is going to come out and multiply against the 2. So negative 6. And then the leftover part, 5, right? That's left over. So root 5. And then 80, which we've done this one already. 2 and 40, 2 and 20, 2 and 10, 2 and 5. So the pairs are 2 times 2, which is 4. So 4. But then they're going to come out and multiply against this. So 4 times 3, right? Both of these. 2 times 2 times 3. So 4 times 3, which is 12. Plus 12 root 5. So we're just combining like terms. So this is 4 minus 6 plus 2. So 4 minus 6, negative 2. Negative 2 plus 12 is 10. 10 root 5. Make sure you're keeping me honest. If I make a mistake, let me know in the comments. It's pretty late. Okay. 8 plus 3, 8, 9, 10, 11. 11 cubed root 6. Right, 8, 9, 10, 11. All of this matches. So we're good to combine them. 6 can't be reduced anymore, right? 2 times 3. Okay. Always simplify first. This is y squared. So when you square square root, it just goes away. So this is really 8y. That doesn't combine with anything. However, these match. So 7 minus 4 is 3. Positive 3 root y. Hey, front page. Let's go. All right, now we are, what was that? Adding and subtracting. All right, now we're multiplying. Okay. You can either simplify first or simplify last. Truly doesn't matter. This is going to be, so let's think about this for a moment. 4 times 8. Right, all this is going to be multiplied together. So all this is going to be underneath a big 4th root. Right, you could look. 4 times 8 is 32. Well, what I'm getting at is that when you're multiplying, right, they're going to go together under one big one. So to kind of like save yourself some trouble, if you start like this, right, all this is going to be underneath one. So I'm looking for a group of 4. So 1, 2, 3, 4. So I know that this is going to come out as a single 2, right? Because this is 4, so we're looking for 4s. So there's my group of 4. This can come out as a single 2. The blue 2 stays inside. Right, this stays. Okay. X cubed, x to the 2. So there's 5 x's up underneath this square root. So that means this 3 and one of these is going to come out. And there's going to be 1 left over. The same with y to the 5th. There's one group of 4 inside of here. And there's going to be 1 left over. So 4th root, what's left over? A 2, an x, and a y. Right, a 2x and a y. All that, like if you multiply these together, they're going to be 32, x to the 5th, y to the 5th. And now you simplify it, right? I would break 32 down using all these numbers I used right here on the left. 2 times 2 times 2 times 2 times 2. And you just take out a group of 4. Hopefully you understand what I'm saying, right? Like if I wanted 10 times 40 is 400. X squared times x is x cubed. Y times y cubed is y to the 4th. Right? I'm saying that you don't necessarily have to rewrite it because you know that you're multiplying and you know that they're all going to go under the same square root. So if you break it down now, 2 times 5, 2 times 20, 2 times 10, 2 times 5, right? They're all underneath the square root. I know they're underneath the square root. So now I'm looking for pairs. So here's a pair, here's a pair, and here's a pair, right? So those are going to come out as a 2. Those are going to come out as a 2. And these are going to come out as a 5. And you multiply all of these together. 2 times 2 is 4 times 5 is 20. So 20 is definitely outside of the square root. Okay. This guy's going to come out, leaving behind 1x. And then there's 4 y's, right? 1 and 3. So both of these are going to come out as y squared. And the only thing left behind is a single x. Is a single x. Okay. Here we have outside times outside. So 7 times 8 is 56. Inside times inside. This is going to be root 4 x squared. Okay. 2 and 2. That's going to come out as a single 2. And then x squared. This is going to come out as a single x. So final answer, right? 2 times 56 is going to be 112. And then x squared is just x. Okay, number 16. If you put this in a calculator, right, we're going to multiply all these. You're going to get a crazy large number. And then you have to simplify it anyway. So it's best to just simplify it now. Right, 26 is 2 times 13. 39 is going to be 3 times 13. 14 is 2 times 7. All right, if you put this under a square root, right, because that's what's happening. Like, it's all being multiplied. You just take out the pairs. So let's take out the pairs now. So a 13 is going to come out. A 2 is going to come out. And left behind are the leftover parts. Right, leftover, leftover. 3 times 7. So final answer, 13 times 2, 26. Root 21. Might have to watch that one a couple times, right? The reason I can do this is because if you multiply 26 times 39 times 14, they're all going to be under the same big square root. So you can factor them now, basically. Okay. Same idea here, right? Except now we're looking at triples. So first off, outside times outside. 4 times 4 is 16. Cubed root, 27 times 8. I mean, I don't have a calculator, so I really can't. I mean, I could, but watch, you'll see. Then x squared and x. So that's really x times x times x, right? X cubed. Right, 2 plus 1. Okay, 27 is 3 times 9. 9 is 3 times 3. 8 is 2 times 4. 4 is 2 times 2. So circling the triples, there's 1 and there's 2. So a 3 is going to come out and a 2 is going to come out. And both of these get multiplied against the 16. So 2 times 3 is 6. 6 times 16. 6 times 16. 6 times 6 is 36. Carry the 3. 6, 7, 8, 9. 96. Right, this is 6 times 16. Okay, and then triples come out. So as a single. And there's nothing left inside. So 96x. All this is equal to 96x. All right. 18. Outside times outside. So this is going to be negative 15. 24 times 20. It's like 480. But if we break it up now, which I suggest do, now we just circle all the pairs, right? Because they're going to be underneath the square root anyway. So here's a pair. Here's a pair. So that's going to be a 2, another 2. And then inside the square root, what's left? 2 times 3 times 5. So 10 times 3 is 30. So outside we have negative 60 root 30. Hopefully you're following along with the logic that I'm using here. Okay, 19. This one's a different one. We can break this up. Square root of the top over the square root of the bottom. That's nice because so when you do this, we don't like square roots in the denominator, right? Square roots in the bottom are essentially bad. Like that's like equivalent to leaving a fraction not reduced, right? Like we don't leave square roots in the denominator. So this is going to be root 5 over square root of 9, which is 3. That's kind of nice. All right, square root of the top, square root of the bottom. So first off, square root of the bottom, 25. Square root of 25 is just 5. All right, 8. See if you can catch on. 8. We have to simplify it. Right? It's not a perfect square, but 8 is really 2 times 4. 4 is 2 times 2. Taking out the pair with 1 left over. So 2 root 2. 2 root 2. All right, 21. Again, we don't like square roots in the bottom. So I have to multiply this. It's called rationalizing the denominator. I have to multiply by something. And the only thing that can multiply by that will get rid of a square root is itself. So this is going to be, so anytime, this is going to be root 4, right? 2 times 2 is 4. And the top is just 11 root 2. Whole numbers and square roots, they just mash up. They just go together. All right, square root of 4, the bottom is just 2. So one thing you learn is that when the insides match and you're multiplying, the answer is just the inside part, right? Root 2 times root 2 is just 2. Okay, that's it for the second page. We're almost done. Let's go. All right, 22. Again, root 7 on the bottom. That's bad, right? Essentially. So root 7, root 7. Well, whatever that square root is, that's immediately what you write top and bottom. And we're going to multiply. So this is 3 root 7. 7 times 7, 7. Right, root 7 times root 7 is 7. Because root 49 and the square root of 49 is 7. Hopefully you can see the pattern. What number am I going to use? Exactly. Root 5. So the bottom's easy. Root 5 times root 5 is just 5. Top, 12, root 5. As far as we can go. Oh, this is a nice one. Because look, square root of the top, square root of the bottom. These are perfect squares. Root 25, 5. Root 16, 4. Those are nice. Those are always nice. Okay. This is, right away I can recognize this is a conjugate pair. Now, we don't necessarily, did we talk about conjugate pairs? I feel like we did, but nevertheless, FOIL is the way to go. 6 times 6, 36. 6 times root 2 plus 6 root 2. Right, when you're multiplying, this would be minus 6 root 2. And this would be minus 2. All right, combining like terms. These cancel. 36 minus 2, 34. Little FOIL action. Okay, so going back here, just something to note. This special relationship where the numbers match, but they're off by, right, they're opposite. This is called a conjugate pair. These come in handy, specifically in this next example. So notice, right, when you multiply conjugate pairs together, the insides cancel when you FOIL them out. So really, there's a little trick that if you notice that you're multiplying conjugate pairs, you don't necessarily have to go through all the motions. But I will on this next one, just so you know. So here, we have a square root in the denominator. This is bad. We got to get rid of it. But I can't just multiply by root 6 like we did in the other examples. It doesn't work. So the idea is that I got to multiply by something. Well, I'm going to use the conjugate pair. I'm going to multiply by 5 minus root 6. Top and bottom. Right, top and bottom. So when you're multiplying fractions, you multiply straight across. So this is going to distribute. That's nice. 1 times anything is itself. So that's nice on top. Okay, on bottom, so really, when you're multiplying conjugate pairs, which they are, right? They're the same numbers. They're only off by a sign, right? One root is positive and the other root is negative. So watch. This is my little shortcut. 5 times 5 is 25. Root 6 times negative root 6 is negative 6. Now, I'm not even going to do the other two because I know they're going to cancel. They're guaranteed to cancel because they're conjugate pairs. So I'm going to leave it at that. So this is going to be 5 root 6 over 19. 5 root 6 over 19. You might have to watch that a couple times. But here, this is a little shortcut that I do. You don't have to do all the FOIL because that middle part right here, this middle part that canceled will always cancel. So I kind of use that to my advantage. Watch, we're going to do the same thing here. See if you can pause the video and work it out. All right, hopefully you got the conjugate pair of 7 plus root 5. Right, it's the exact numbers, but with the opposite symbol. And whatever that is, I got to do top and bottom. Right, top and bottom. So distributing, negative 42, negative 6 root 5, all over. So 7 times 7, 49. Negative times a positive is negative. Root 5 times root 5 is 5. So this is going to be negative 42 minus 6 root 5 over 44. Now notice all of these are even numbers, right? 44 is an even number. 6 is an even number. 42 is an even number. So I can essentially factor out a 2 from everything. And you don't need to write the 2 anywhere. The 2's will just cancel out of everything. So this would be negative 21, right? Because I'm dividing by 2. Negative 3 root 5 all over 22. Okay. That's that. How many more we got? Second to last one. Let's go. Okay. I need a little bit of room for this one. So here we have, again, a square root's in the bottom. That's bad. I have to handle that. I don't care about the top. So I'm going to multiply by the conjugate pair, right? Because there's multiple things here. So 3 minus root 7, top and bottom. Okay, top. This is going to be 3 root 2. This is going to be minus root 14. Okay. On the bottom, 3 times 3 is 9. Minus 7. Right, because root 7 times root 7 is 7. This is going to be final answer. 3 root 2 minus root 14. Right, no, I can't get any more simple than that. 14 doesn't reduce. And then 9 minus 2 is, or 9 minus 7 is 2. All right, 19. Last one. Again, square root, and it's a minus. So I'm going to use the conjugate pair. This is going to be 8 plus root 7. Top and bottom. Okay, top, easy. Distribute. 32. Distribute. Plus 4 root 7 over 8 times 8, 64. Negative times a positive is negative 7. Right, root 7 times root 7, 7. All right, this is going to be 64 minus 7. 53. So final answer, 32. 4 root 7 over 50, not 53, 57. All right. All right, hopefully this helps someone out. Is that it? Is there another page? No. All right. Catch you guys in the next video. Peace.